Hi guys. So today we're going to be talking about various segments that intersect the circle and the relationship between the lengths or the parts of the lengths. Okay? So in this first case, we have a circle with two chords that intersect inside the circle. Okay? When that happens, the relationship is that the product of individual parts for each chord is the same. So for example here, x times y is equal to a times b. We can use that to solve problems. So let's look at our first problem. Okay, we have a chord that is made up of y and 10, so 10 times y, and that has to equal the product of the parts of the other chord, which is 15 and 7. So 15 times 7. So 10y is equal to 105, which means that y is 10.5. Okay. Now, we can also have chords that intersect outside of a circle. Okay, so here we have two secant segments. Here we have a tangent and a secant, and we have two tangent. Okay, so the relationship is slightly different for when the chords meet or segments meet outside of the circle, because we are going to take the length of the entire segment. So here is AB times the length of the part that is outside of the circle. So B, and that has to equal the product of the length of the other segment, which is C plus D, times the length of the part that is outside the circle, which is C. Okay? The same rule applies when we're dealing with a tangent. So, remember, it's the length of the entire segment, so E, times the part that is outside of the circle, which is also E. So this is why in the formula right here we have E squared. Okay, because E times E is E squared. And then for the secant segment is the length of the entire segment, which is F plus G, times the length of the part that is on the outside. Okay, now when we're dealing with two tangent segments, we could apply the exact same rule. So the length of the entire segment times the part that sticks out would give us h squared is equal to I squared, which can simplify to just h equals I. And you guys seen this relationship before when we talked about tangent segments. So now let's look at example problems. Okay, so in the first case, I have a tangent with length of 6, okay, and the part that sticks out is also 6, and that has to equal the length of this segment, which is 9 plus x, times the part that is on the outside, which is x. Okay, so this gives us 36 is equal to 9x plus x squared. This is a quadratic equation, so we're going to get everything to one side and make it equal 0. And then to solve it, we were going to factor it. So negative 36 on top, 9 on the bottom. The two numbers that multiply to negative 36 and add up to 9 are 12 and negative 3. So we get x plus 12. X minus 3 equals 0, which means that x is negative 12 or x equals 3. Now, obviously, since we're dealing with length, we cannot have negative in the answers, so the answer is x equals 3. Okay? In the second case, we have two secant segments. So the first one, the length of this segment is 25. The part that sticks out is equal to 4. Okay. For the second segment, the length of the entire segment is 11x plus x, which is 12x. And the part that is outside the circle is x. So this gives us 100 is equal to 12x squared. And that means that x squared is equal to 100 over 12, which simplifies to 50 over 6. So x is equal to square root of 50 is going to be 5 square roots of 2 over square root of 6, which simplifies to 5 square roots 5 over square root of 3, which is the same thing of 5 square roots of 3 over 3. Okay, and there you have it. So notice that in these problems, we're probably going to see a lot of quadratic equations, and this is because of these products. Okay, so please watch the solutions to our practice problems next, or try to doing them on your own.